More water! Yay! But wait, there's more. So we're actually not just going to talk about water, we're going to talk about acids and bases in water today. So your kind of starter for the day is how many grams of sodium chloride are in 14.3 liters of a 2.38 molar solution. So you should be able to do this from molarity and from what we learned in the last video, but you should take your 2.38 molar, multiply it times the liters. That should then give you just moles, and then you need to convert from moles to grams of sodium chloride to figure out what that is. So the Arrhenius definition says that an acid produces H3O plus, and that a base produces OH minus. The Bronsted-Lowry definition is a little better in that it says that acid is a proton donator and a base is a proton acceptor. Now, both of these aren't wrong, but there are some nuances to them. But the Bronsted-Lowry is the one that we tend to use the most and feel that it's the most apt description. So acids are proton donators, H plus donators. Why do we call H plus a proton? It's because a hydrogen atom is a proton and an electron. If it's a positively charged, it's lost the electron, so it's just a proton. Now, it can't just exist by itself. It has to attach itself to something else, which is why we tend to also write that it's either H plus or H3O plus, because typically when it is donated, it's accepted by a water molecule and it forms the H3O plus ion. So strong acids are assumed to be 100% ionized in solution. They're good proton donors. So a strong acid is something like hydrochloric acid, HCl, sulfuric acid, H2SO4, nitric acid, HNO3. Weak acids are usually less than 5% ionized in solution. They are poor proton donors. They're not good at giving up hydrogen ions, but they do give up some. So things like phosphoric acid, H3PO4, acetic acid, HC2H3O2, that's what's in vinegar, or other organic acids. Acetic acid is an organic acid, but there's lots of other organic acids. So acids have a pH less than 7. So we're looking at things that are from here down in number. So things like battery acid, lemon juice, gastric fluid, carbonated beverages, vinegar, orange juice, beer, coffee, eggs, yolks, milk. Pure rain tends to also have a little bit of carbon dioxide dissolved in it, which forms carbonic acid, which makes it slightly acidic. Freshly distilled water should be right at 7, right at neutral. So acids taste sour. Organic acids are weak acids, and a lot of are used as flavoring agents in food, but they're also naturally occurring in things like lemons and oranges and most fruits. So citric acid is in citric fruit, malic acid is in sour apples, lactic acid is in sour milk and in sore mussels. Butyric acid is in rancid butter and vomit. Organic acids all contain the carboxyl group and sometimes have several of them. So it's a carbon double bonded to an oxygen, bonded over to another oxygen, and then to a hydrogen, which is the ionizable hydrogen. The carboxyl group is a poor proton donor. It's not good at giving up its protons, so all organic acids are weak acids. So acids affect indicators. It turns blue, litmus paper turns red in contact with an acid. Methyl orange turns red with the addition of an acid. Phenolphthalein goes clear. There's lots of different acid-base indicators that it can affect. Acids react with active metals. So acids react with metals to form hydrogen gas. So magnesium will react with hydrochloric acid to form hydrogen gas, with zinc, with magnesium, any of these strong acids in particular. Weak acids will react with certain metals. Strong acids will react with more metals. And then there's some metals that just aren't reactive. So acids react with carbonates. So if you add acetic acid to washing soda or baking soda, it will react to produce carbon dioxide and water and a salt. So sodium acetate is the name of the salt that's formed when you mix when you mix bicarbonate of soda or washing soda or sodium carbonate with acetic acid. So one of the interesting things is other carbonates like calcium carbonate, which is what's in marble or limestone, will actually begin to dissolve things. So you get George Washington. This is an early picture of a nice marble statue of George Washington, and then acid rain happens and you get zombie George Washington, one of my favorite presidents, because it starts to dissolve all of the weaker parts in that marble and he looks like he has some horrid disease. So acids neutralize bases. Neutralization reactions always produce a salt and water. So a salt is an ionic compound. So hydrochloric acid and sodium hydroxide form sodium chloride or table salt and water. Sulfuric acid and sodium hydroxide form sodium sulfate and water. Nitric acid and magnesium hydroxide form magnesium nitrate and water, right? A salt and water, a salt and water. Despite the heavy flak, McAllister's aim was true. His carefully measured aliquot of hydrochloric acid found its mark deep in the enemy's reservoir of sodium hydroxide. McAllister grinned widely, wryly. Finally, one of the enemy's strongest bases had been completely neutralized. So a reaction between an acid and a base is called a neutralization reaction, and sodium hydroxide, potassium hydroxide are both strong bases. Terrible, terrible chemistry jokes. And on to bases. A base is a proton acceptor. The most common strong bases are proton acceptors because they have a hydroxide group, OH, and it combines with H plus to form water. So sodium hydroxide, potassium hydroxide, magnesium hydroxide, calcium hydroxide are all strong bases because they contain hydroxide. So bases have a pH greater than 7. So we're looking at everything from here to here. So blood, seawater, baking soda, milk of magnesia, household ammonia, household bleach, and household lye. So if you'll notice, your blood is slightly, yeah, you're basic. You really are, at least a little bit. We all are. So bases affect indicators. It turns red, litmus paper will turn blue in contact with a base. It turns phenolphthalein bright pink in a base. That's that funny word, phenolphthalein. It shouldn't really wrap over. Anyway, that N's supposed to be at the end of that word, but whatever. Bases neutralize acids. This is why we take things like milk of magnesia. It contains magnesium hydroxide, which neutralizes stomach acid. When you have heartburn or something like that, it's acid reflux, and so they try to quell the acid. Hydrochloric acid and magnesium hydroxide produces magnesium chloride and water, right? A salt and water.